What if quantum computers have unlocked a force so powerful it could reshape reality itself? For years, scientists have speculated about the true potential of quantum mechanics, warning that we may be on the brink of discoveries that challenge everything we know about physics. And now, something unprecedented may have happened. Renowned physicist Michio Kaku has long warned that quantum technology could collide with the fundamental forces of the universe in ways we don't yet understand. In 2014, Stephen Hawking issued a dire statement. The God particle found by CERN could destroy the universe. One day, a catastrophe could wipe out space-time itself. Hawking warned that at very high energy levels, the Higgs field could become unstable, leading to vacuum decay, a scenario where the universe collapses into a lower energy state, potentially erasing all known reality. Until recently, this was considered an extreme theoretical possibility, requiring energy levels far beyond what humans could produce. But now, with the emergence of quantum AI, scientists may have unknowingly taken a step too far. A recent breakthrough suggests that quantum processors might be interacting with the Higgs field in ways never before seen. Could this lead to reality manipulation, uncontrolled energy shifts, or even access to dimensions beyond human comprehension? And if this discovery isn't just about physics, could we be on the verge of understanding something deeper about existence itself? What was discovered? If quantum AI is directly influencing the Higgs field, then we may have crossed a dangerous line, one between observation and manipulation. The Higgs Boson, discovered in 2012 at CERN's Large Hadron Collider, LHC, should behave in a predictable manner, following the standard model of physics. But new quantum simulations show unexpected fluctuations in mass itself, as if the Higgs field were reacting to quantum computations. One lead researcher described it as like watching ripples form in a still pond, except we didn't throw a stone in. This suggests that the Higgs field is not just passively being studied, it may be responding. Physicist David Deutsch, a pioneer of quantum mechanics, once theorized, a sufficiently powerful quantum system might be able to simulate and even alter the laws of physics. Have we reached the point where simulation has become interaction? The implications, reality manipulation. If the Higgs boson is truly the fundamental particle responsible for mass, then any shift in its behavior, even at the quantum level, could have unpredictable effects. Physicists are now seriously considering possibilities that once seemed like science fiction. Can mass itself be influenced at a quantum level? Could quantum AI discover entirely new forms of energy? Are we on the verge of controlling, creating, or even destroying matter? The God particle and why it matters. The term God particle isn't religious. It refers to the Higgs boson's crucial role in shaping the universe. It determines why matter has mass, making stars, planets, and life itself possible. But some scientists believe we've only scratched the surface of what this particle can do. The Higgs field, the invisible force that governs mass, could be far more unstable than we realized. In a 2014 interview, Peter Higgs, the scientist who first proposed its existence, warned, "If the Higgs field is unstable, it could mean the collapse of everything we know. If the Higgs boson is the glue that holds reality together, then what happens if we start experimenting with it in ways nature never intended?" For years, physicists assumed the Higgs boson was simply a missing piece in the standard model, but now quantum AI is revealing anomalies that suggest it may be something far greater. Quantum computing, the game changer. Unlike traditional computers, which process information as ones and zeros, quantum computers use qubits, which can exist in multiple states at once, a phenomenon called superposition. Quantum computing pioneer John Preskill once said, "Quantum computers aren't just tools, they could redefine how we understand fundamental physics." That's exactly what's happening. In 2023, CERN scientists used quantum algorithms to simulate Higgs boson interactions with unprecedented accuracy. But something strange occurred. The data showed unexpected fluctuations, patterns that standard physics couldn't explain. Some researchers believe that quantum AI may not just be simulating the Higgs field anymore, it might be interacting with it. If this is true, quantum computers may be tapping into something beyond physics, something that could lead to a complete transformation in our understanding of reality. And here's something else amazing to consider: the quantum measurement problem. Could observation be shaping reality? One of the most mind-bending mysteries in quantum physics is something known as the quantum measurement problem, the idea that at the smallest scales, reality doesn't seem to exist until it is observed. In classical physics, objects exist independently of whether anyone is watching them. A rock is a rock, whether you look at it or not. But at the quantum level, particles exist in a superposition of all possible states until they are measured. This was famously demonstrated in the double-slit experiment, where electrons, when unobserved, behave like waves, passing through both slits at the same time. But the moment they are measured, they choose a specific path and behave like particles instead. This suggests that observation, or perhaps consciousness itself, plays a fundamental role in shaping reality. Now let's connect this to quantum AI and the Higgs boson. If quantum AI is now powerful enough to analyze the Higgs field, could it be acting as a kind of ultimate observer? Some physicists speculate that the act of observing quantum systems with extreme precision could actually be affecting them. If the Higgs boson is shifting in response to quantum AI's analysis, we may be witnessing the first large-scale proof of the quantum measurement problem influencing fundamental forces. Michio Kaku has suggested that quantum computing could one day provide evidence that reality is fundamentally connected to observation. If this is true, it would mean that the Higgs boson, responsible for giving particles mass, may not have a fixed state until observed. Quantum AI's extreme processing power might be creating new forms of quantum interference, altering the results in ways we don't yet understand. The observer effect could apply not just to small particles, but to the very fabric of space-time itself. The implications are staggering. If quantum AI is serving as an observer on a scale never before possible, then could we be witnessing the first direct evidence that consciousness, or intelligent observation, can shape reality? This would completely transform our understanding of physics, free will, and even the nature of existence itself. And here's where it gets even stranger. If quantum AI is analyzing reality so deeply that it's affecting it, how do we know we're not already inside a quantum system ourselves? Could this be the first clue that we are living in a simulated reality? If so, what happens when we push further? Would we discover the true nature of the universe, or unintentionally rewrite it? This new connection between quantum AI, the Higgs boson, and the quantum measurement problem could be the missing piece in understanding why our reality behaves the way it does. And if Michio Kaku's warnings hold any weight, we might not be ready for what comes next. Michio Kaku has been one of the most vocal scientists warning that quantum computing and AI may be more powerful than we realize. In a recent interview, he stated, "We're on the verge of a second quantum revolution, one that could give us control over nature itself or unleash something we don't understand." The dilemma is clear. If quantum AI can control mass, energy, and even space-time, what else might be possible? Physicist Max Tegmark, an expert in AI and quantum mechanics, warns, "The difference between a tool and a weapon is often how well we understand its power." And right now, we don't fully understand quantum computing's true capabilities. If we've already altered something at the quantum level, there may be no way to undo it. Kaku has always emphasized that science is about pushing boundaries, but he also warns, the laws of physics are not a guidebook for human ambition. They are the limits of what we are allowed to do. The question now is, have we just stepped beyond those limits? Could quantum AI be manipulating reality? As quantum AI pushes deeper into uncharted territory, some physicists believe we may be witnessing something far more profound than just advanced calculations. Traditional computers process data within the constraints of classical physics. Quantum systems operate at a level where the laws of nature are still being defined. If quantum AI is interacting with the Higgs field, even the smallest disruption could have unintended consequences. Some researchers worry that altering the Higgs field, even in microscopic ways, could create ripple effects that extend beyond the quantum system itself. This raises an unsettling possibility. What if quantum computers aren't just simulating reality, but actively shaping it? What happens next? Physicist Brian Greene once said, "We are just beginning to understand quantum reality. What we find next could change everything." Some believe this could lead to groundbreaking advancements, new energy sources, advanced space travel, and a deeper understanding of the universe. But others worry that we've already crossed a threshold without realizing it. One thing is certain, we are now in completely unexplored territory. If quantum AI has already begun interacting with the Higgs field, then what happens next is unknown. The only question left: are we truly ready for the consequences of unlocking the God particle?